Hello everybody, are you able to hear me? Okay, nice. Okay, now do you have any problem so far? So about the single degree of freedom system, okay? So especially the chapter 4, the transient vibration. So any confusion you have after seeing the video lecture? Okay, no confusion? Okay. Okay, so we'll start with the tutorial problem. Okay, so the tutorial problems are actually relatively easier. Basically, it's once you know the other chapters, meaning the single degree of freedom system, uh, and the free vibration, the harmonic vibration, and then tangent vibration is easier. You understand if you understand those topics. Okay. So hold on. Okay. So the question is question in the quiz: which spring is given x2 harmonic displacement and the damper is attached to the wall, and we have to find the force on the wall. Yes. So how to find it? Yeah, it's okay. So the problem look like something like this, right? So you had a damper here, right? And then you have a mass here, Cm, and then you have a spring here. Okay, so this one you say x1, this you say x2. Okay, so you have to find out the force here. So how to find the force, right? That's what the question was probably, yeah? Okay, so the force will be what? Force will be simply F equal to Cx dot x1 dot, right? This is what the force will be. If you see the if this has x1 dot, the mass has the velocity x1 dot, then force, the opposing force will be cx1 dot, and hence if you see on both the sides, if this side is cx1 dot, this side also it will be cx1 dot only, right? So has to balance, and hence the force here, force transmitted ft will be cx1 dot only. Yeah, so if you can find out x1, take derivative of that, you get the value of the force transferred to the wall. Yeah, it's okay. Understood? Any more explanation is needed?
Sir, the x1 is x2 under
Yeah, go ahead.
like that. Sir, that
No, I can't hear you. Aditi, are you saying something? Actually, I'm not able to actually hear. Okay, just hold on, please. So kx2 was the value of x1, and after that I was not able to do. Okay. Okay. Well, how to solve this one? First of all, you have to find out this is k, right? So you have to find out what will be the equation of equilibrium, or the equation of motion, basically. Okay. So how do you do? First, you find out what is the equation of motion. Yeah. So first you write this. So if we have m, and then after that, what do you get? Here you can assume here x2 is greater than x1 in this case, right? So what is the meaning of that? That means this is a stretch, and hence the force will be this way. And how much force? Force will be k x2 minus x1. This will be the force. This is by which it is going to a stretch. The force will be this way, right? Here x1, so the force in this case will be cx1 dot, right? Hence the equation of equilibrium becomes equal to this one is x1, right? So you have k x2 minus x1, right? Okay, and then minus cx1 dot becomes equal to mx1 double dot, and final equation becomes mx1 double dot, right, plus cx1 dot plus kx1 is equal to kx2, right? This is the equation, right? Now x2 is given a sine omega t, something like that. Okay, it's given. So hence you know the force. This is something like force, right? So this is equal to force, basically, right? Where force equal to a k kx2 equal to ka sine omega t. So then you have to solve, right? Just this you solve, and then you get it. So mx1 double dot plus cx1 dot plus kx1 equal to ka sine omega t. That's what you have to solve. This is a standard force vibration problem. And then you find out what is x1 is. Expression of x1 you get, right? Find out x1 equal to what in terms of x1, the function of time you have to find out. Yeah, the value will be then the if you get x1, then you differentiate it, multiplied by c, you get the force. I did this problem here, no? So although it was not exactly the finding out the force at the wall, okay, but this problem is in your textbook, and their idea was something else, but I used the same diagram, same problem, but this time it was finding out the force transmitted, but the equation remains the same. Got it? Okay, okay, great. Okay, any other comments, guys? Can okay, one question is, can we replace Ka directly into the equation that we had already derived for xt? Yeah, you can do it, so but that comes from experience, so if you solve a lot of problems, then you will know, just we have to multiply k times x2. A times x2 will be the force actually, related the force with respect to x1. So it makes sense that way. But you know, it is not straightforward. Always, I will always suggest that you go as per this. You know, so this is more. Uh, this is the right way of doing it. You will not make any mistake. If you just go by, okay, this will be a stretch, this is to this one, so you can do it. You can do it, but you know there may be some problem somewhere which will not make sense, and you will make a mistake. So what I would say is, it all comes from your experience. More you work, solve these problems, more you will know that in this kind of problem, I will just do it like this. But why you do like that? What was the logic? That will come after experience only. Yeah. So I would say yes, you can do it, number one, but I will advise not do it. Yeah. So you solve from the first principle. Start with the basic equation. That way you will be more. Here also you are showing the actual which of forces are coming here in the writing the right way. You know, so this is the right way of doing it. Yeah. Okay. Yeah. Any other question, guys? Any other issues, guys, related to the quiz? I would just request that you guys see the video lectures regularly as soon as possible and do the problems, you know. So waiting till the quiz is not a good strategy, and that way things will not make sense. Yeah. So some comments saying that the quiz had a long quiz, we needed a lot of time. That really means that you did not understand basically, because problems, there are few problems we are like just looking at this you will know the answer. You know, quite a few questions had zero answer, because you know that in free vibration it depends on initial velocity and initial displacement. If both are zero, final everything is zero. Zero velocity, zero displacement, zero acceleration, you know. So this insight you have to get. It's not that put a things in is in some equation and you get the answer. That's not right way basically. You also have to feel the course, you know. So mechanics has some kind of, you can feel basically. So it has physics, it has mathematics, the mechanics is a right course. So this is part of mechanics of dynamics basically, right? So this is the right course to actually understand mathematics even. You know, you will understand what is the physical meaning of mathematics and all. You know, so you have to really study and solve the problems, and that way it will make your life easier later on. Yeah. Okay. Any other question, guys? Okay, so we will start with now, since there is no other question, we'll start with tutorial problems. And tutorial problems, what I'm going to write, the number, if I write number like 4.4, like this one, let me write differently. So when I write 4.6 like this one, that really means I'm talking about the ebook. Okay, in bracket I will write 4.4. That really means we are talking about the paperback. Okay, so and this is okay. So I'm going to solve this one 4.6. Okay, this problem, and what it says is this is revisiting the other problem. Only thing is the arbitrary force which is applied here. So on a spring mass damper system. So this is a spring, this is a damper mass here, M, this is K, C, and arbitrary force being applied, which is Ft. Okay. So what it says, If an arbitrary force Ft is applied to an undamped oscillator, okay, this is undamped. Okay, this is undamped, so only a spring here. That has initial velocity other than 0, show the solution must be of some form. So solution is given, you have to show something. Okay, so what is the difference? Earlier what we saw was basically we assumed that x dot 0 equal to 0 and x 0 equal to 0. We assumed from there we started, okay? Okay, there is one question. Okay, you have to wait. Okay, Ashutosh. Okay, so since I started explaining this one, so after that I will come back to you. Okay. Yeah. Okay. So. Okay. So basically, the only difference here is this is given. Okay. Initial values is not equal to 0 in this case. Now, so this value is given x 0 equal to x naught and x dot 0 equal to v naught. They are given, then how to solve this one. Okay. So earlier, how did we solve? You have to write the equation. So mx double dot plus kx equal to ft, right? This is the equation, and then you can solve it by Laplace transform. You apply Laplace transform, then you get m, then s square x s minus, then you get x at equal to 0, then s minus x dot equal to 0. Okay, so you get this plus kxs equal to fs. You get like this, and then what do? You find out what is the xs is. So xs becomes equal to fs. Okay, then also you have x naught s plus v naught, and divided by you have s square ms square plus k. So you have this. You can write xs final form equal to fs divided by ms square plus k, plus you have x naught s plus v naught over ms square plus k. Then you take the inverse Laplace to get the xt. So xt will be like this of xs, and then you have this value, right? So we have shown that already this value is nothing but 0. You get 0 to t, and then 1 over m omega n, right? Then you get ft, then you have sine, this is not t but tau sine t minus tau dt. So you already know that this is how you will solve it, right? So the inverse Laplace of that will be this value. This we know already, and inverse Laplace of this will be, you can find out from here, will be x naught cos omega nt, and from here becomes plus v naught omega divided by omega n sine omega nt. So this term will automatically come into picture. Yeah. So this is how you can solve it. Okay. So now I take up the question by Ashutosh. So half power points, but we haven't used it anywhere. What was the significance of finding that? Okay. half power points, basically we used it basically, yeah. So maybe it was not clear probably. That's why you are asking. I'm going to explain it again. We used it. Omega 1, omega 2 are actually the half power points. So, so this is the omega versus our x, right? We call it x naught. The x naught. X naught is the amplitude, right? So we are talking about any spring mass damper system, right? So this is K, this is C, and there is a xt, right? So what we are going to do? The force is being applied if uh, which will, which is a function of omega basically, right? So that really means this will be like something like f naught sine omega t. So this is like this. Yeah, this is the force, harmonic force, which is being applied to a spring mass damper system. Yeah. So if omega is equal to 0, then you have just f over k is the displacement, f naught over k. Yeah. So f naught over k is displacement. So from here it starts. It will go up, and it will come down and go like this. Yeah. So this is how it is going to be. Now, what we are assuming is that the highest point will always be corresponding to omega n. This omega n, right? So this value from here to here is, let's call it xn. So this is xn. Half power points means, as I said earlier, power is proportional to xn square, right? So power, let's call power proportional to xn square. Half power will be proportional to xn square divided by 2, right? Like this one. So half power points are where half of the square of xn we are going to see, right? So half of a square of xn will be, let us say, is somewhere here. So value of this, one will be here, let us say, call it, and the other will be here. So these points is omega 1 and omega 2. Yeah, and we define the sharpness of the resonance in terms of this only, right? Sharpness, the Q that we defined was what? Equal to omega n divided by omega 2 minus omega 1, right? That's what we did, right? Yes. Now, see here, what is the meaning of this? And from here to here should be a square root of, the value will be what? Here to here will be a square root of, so this will be xn divided by root 2, right? So that if you square it will be half of that, right? So this becomes both the side, this is xn over root 2. Let's call it x2 here. This will be x1. So both x1 and x2 equal to is equal to xn divided by root 2, and corresponding omega is omega 1 and omega 2, right? So this is half power points, right? Half power points. Half power points means omega basically. Omega 1, omega 2. Yeah? Got it, Asutosh? Okay. Any other question, guys? Okay, so let's take up more questions. Okay, now let's look at uh, 4.343, yeah, which is 4.5 also. So this problem shows that the time Tp corresponding to the peak response of a damped spring mass system excited by a step force F naught is WNTP equal to pi over root 1 minus zeta square. Okay, so what is needed? Basically, there is a spring mass damper system. And there is a force being applied, so a step force. So this is F, where F is a step force, right? So F is like this T, and you have a step input like this. So from here to here is F naught, right? See, a step input. So we already actually solved this one, right? In one of the lectures, you will see for given this kind of force, then what will be the xt looks like, yeah, xt equal to what in this case, and the solution will be something like this, yeah, xt will be equal to, we have f over m omega n square, so it becomes k, and then you will have 1 minus e to power minus zeta omega nt divided by root 1 minus zeta square, then you have cos, then you have omega d term will be there. So this will be root 1 minus zeta square omega n t term will be like this. Okay, there will be a phase as well. So plus psi, we call it. Okay, so this is the how the x will be there, right? So we have derived already in one of the lectures. You can look at it, or you can see in the book. Okay, okay. So given that, what we have to find out, we have to find out x max. Okay, maximum xt, right? That we have to find out maximum displacement. If you can also find by plotting it. You know, just you plot it. You will plot, you will find out. So again, x equal to 0, at equal to 0, x dot equal to 0 equal to volume, sorry, the velocity is also 0 at equal to 0. So these conditions are given already. Hence, what will you do? It starts from here. So let us say this is final f over k. So this is f over k value. Yeah. Okay. And then what you will do? You are going to start from here. Of course, you are at x equal to 0. This is t. This is x. So it will start from here, go up like this, and go like this. Yeah. This is how it will look like. Yeah. So it is starting from 0. Then will go up and finally settle at f over k, right? Because that is the final force f naught over k. Sorry, this is f equal to f naught. So what is f? F equal to f naught unit step function. So this is the function f naught. So this is settle at f naught over k. That is the final. In long term, this will go settle on this one. Okay. So I mean the question, if you asking what is this value from here to here is equal to what? Not exactly that. It is asking something else. Just a minute. So that a time corresponding to peak response of damped spring mass system excited by a step force is this one. So basically there is one relationship, and that exists for this point. Okay, and that what relationship you have to show. Show what? Show you have to show what Wn omega n Tp. So this is the time Tp. This is Tp here. This time is Tp here. This is the peak. Peak x corresponds to time Tp. So it says you have to show that omega n times Tp is equal to pi over root 1 minus zeta square. That you have to show. Okay. So given this one, then we have to find out the maximum xp, right? This is the maximum you get. This is the maximum. And in order to get maximum, okay, by the way, here psi, so tan psi is equal to zeta over root 1 minus zeta square. That also we derived. So both derived together basically. So in one of the lectures, you can see it. How to solve this problem? You know that you have to find out maxima. So here velocity will be, velocity has to be 0. Maxima is where, maxima or minima, one thing has to be there, the velocity has to be 0, right? So because in other, and also looking at from the calculus, you know the maximum minima, that it really means dx over dt equal to 0 in this case, because x is a function of t. Maximum minima means that dx over dt equal to 0 or velocity equal to 0 in this case. The interpretation of this is okay. So what will you do? You take derivative of this and make equal to 0. Yeah, and from there you can find out as well as that. So if you apply this one, so dx over dt equal to 0, and corresponding after that corresponding Tp, you make t equal to Tp. So step 1, make this equal to 0, and then put t equal to Tp, and then when you do that, automatically you will find out. So basically, if you do that, then this will automatically taken care of. What we will find out is the value. If you do this one, then you will find that sine, and you will get like this: root 1 minus zeta square omega n Tp, yeah, has to be equal to 0. That's what we will find out finally. Okay, and then that really means what? That really means root 1 minus zeta square omega n Tp is equal to pi, yeah, and hence Wn omega n, hence you will get omega n Tp is equal to pi over root 1 minus zeta square. Just try that. Any question, guys? This is a standard calculus. You have the function, and you find out. You know that this is the nature of the solution will be. You can find out. You know that the first peak will be the highest peak. Yeah, if you plot, also you can find out. So hence also the value has to be equal to pi only. Yeah, not like 0, not like 2 pi, because if you put 2 pi, it's too gets smaller and smaller. Yeah. So any question, guys? Did you understand? Any? Let me know if you have any confusion. Okay. Guys, my solving here is no alternative of your actually solving these problems yourself. So always you should solve this, and then you watch this one. So that way you understand more. You can ask question, so rather than my solving here, I think you should solve, and if you face any problem, just let me know. Okay, so based on this, actually there are other problems that will use this basically. So one of them is this problem. So this problem number, just hold on please. Okay, so first is the 30. Yeah, so 4, this problem. Okay, and what is the problem? Problem is like this. So 30 degree here, and there is a mass m like this. Like this one. So this is sliding. Say a spring mass system slides down a smooth 30-degree inclined plane as shown in the figure. Determine the time elapsed from first contact of the spring until it breaks contact again. Yeah. Okay. Now this is based on the problem that we solved today. That was based on 4-6. So this is based on will not exactly based on that, but we'll try. Okay, so I will not write that. So anyway, so this is mass is sliding. This is spring K like this one, and what it says, time elapsed when it will come sliding, and then it will make a contact, and then after that it will compressed, and then after that again it will expand, and after that this will leave the contact, right? So it is finding a, you have to find out TC equal to contact time of the spring, that you have to find out. So how will you do it? You have to first understand like what equation here it applies. Knowing theory is one thing, applying the same is another. Yeah, so here the problem is given, you have to apply. You have to now, it's not given what kind of force, you have to figure out what kind of force it is. Yeah, so what kind of force it is, yeah, if you know the, so distance is also given. So it says from here to here the distance is s, that is given here. So distance initial from here it is falling is given, s is given for a purpose. Okay, so first you have to figure out the type of force it has. The type of force will be, the force is constant if you see. Okay, why force is constant? You can see like this. So the force is being applied here, and what is the force? Force is due to gravity. So this same setup. If you have in a space there is no gravity, it will not go. It will just stand right there. Yeah, but only when you have this under gravity, this will slide. Yeah? So the force, this incline like this, and here you have mg, which is downward, mg downward, and this one is theta. Okay, so this is 90 degree. Yeah, so this angle is in this case this is 30 degree, and this is becomes 60 degree. Okay, so like this one, this is mg, and this is 60 degree, like this 60 degree. Yeah, so mg cos 60 degree or mg sine 30 degree, right? So yeah, this is the force which will be deriving is downward, right? So the force is simply F equal to mg sine 30 degree, yeah, or equal to mg over 2 is the force. This is the constant force being applied, yeah, okay, and that force is downward, always it's applied regardless of where this mass is, that force already there. So this will be equivalent to, this is equivalent to like this one. There is a mass here m, and you are applying a force F here, which is equal to mg over 2, and this is going to hit, right? Because of this force, this will also have some acceleration, and this is going to hit it. Okay, so there are two parts here. The first part, you have to figure out when it goes and makes a contact with it, what is the value of velocity. So in this case, we have to find out what is the initial velocity and what is the initial displacement. When do you want that? This system will finally be equivalent to this system, right? Going up like this one, yeah, from the mean position. And there will be x0 value, there will be x dot 0 value, both of them, yeah. Okay, so first we have to find out what is the velocity when it hits this one, yeah, when this gets in the other end of the spring, gets in touch with the wall here. And how will you find out? You can find out by, so the acceleration is given, so acceleration A equal to mg over 2, so you can write equal to force divided by m equal to g over 2. This is the acceleration. Given the acceleration, you can find out, you can apply b equal to u plus at, but we don't know time, but we know the s, then not that, then you find out b square equal to u, b square u square plus 2as, right? So you can apply this formula then. So all these things, all high school. So what you get? U here, this is u, which is equal to, our initial point is this one. We are assuming there is no velocity. There is no velocity right here. Then, and we just release from zero velocity. Yeah, so final velocity, what do you get? V square equal to 0 plus 2, and A is g over 2s. So V square, what do you get? V square equal to gs, or V equal to gs, root gs. So initial velocity, in this case, initial velocity, we get equal to root gs is the initial velocity. Yeah, and what is x naught? X at 0. In this case, you can assume x0 equal to 0, because we are now talking about this system. Okay, so from this system, what we find out? We find out what is the initial acceleration. Then from this system, we find out when the spring in touch with the wall, then what is the initial velocity. And once we have this data, we prepare the data here. Finally, we have this system where x at t equal to 0, we have 0 displacement, and at t equal to 0, we have x dot equal to root gs, and all others now irrelevant. Yeah, so we don't need that. Okay, now the thing is, it says our time now starts from here, so it will go up and then come back. When it comes back to the same position, then we know that it is going to leave that, because the spring is not attached here. As long as there is no compression in the spring, it will just leave the contact. Yeah. So what we want to know is when it goes back and comes back to the same position, we have to count the time starting from here and start the stopwatch here, and then we have to stop the stopwatch when it comes back at that point, right? Okay, so this is the final problem, and that from there we have to go ahead. Yeah, so now it comes back to simple this problem where x is given, this is going this way up, yeah, and then x is given 0 is given equal to 0, and x dot 0 is given equal to gs. Yeah, so this is the, but one thing more, it has a force also applied, F equal to, there will be force applied which is equal to mg over 2. So this is the, what the thing is, the force is applied like this one, and then we have to solve this one. Okay, now we have to find out that this is m here. Yeah, okay, now this problem is same, little bit the same as the problem number, the first problem we solved today. So the problem in 6, what it says, 4.6 we solved today, right? 4.6 means 4.4, and as per that we have to show that xt equal to xt is equal to x naught cos omega n t plus v naught over omega n sine omega n t plus 1 over m omega n, and then we have convolution of f tau sine omega n t minus tau theta. Okay, so this we solve like for any arbitrary force. If you have the initial displacement, initial velocity, they will come into picture here, and the same equation, these are nothing but the free vibration term. So along with the actual solution, because of the this force now can be taken as the step input now. Yeah, for a step, this will be something like a step input, but however you will have the initial condition as well given there. Yeah, so if you have the initial condition there, the solution will be, we can find out the solution applying this only. So one of the problems that we solved for 4.46 in your ebook, 4.4 in your paperback, same formula if you apply here, and you can solve it. The idea is to get the to apply the initial conditions basically, right? So, okay, now for this one, xt will be given as, okay, xt will be given as, now our displacement is x positive this way now. Okay, remember we are xt is positive this way, so we can directly apply this equation. So xt equal to x0, we are assuming equal to 0, so this term is not there. Second is v naught is v naught over omega n, so root gs over omega n. Okay, and then sine omega nt. So this is coming from the initial condition. Initial condition says velocity is not equal to 0, hence this term will be there, plus the actual term which will be due to the step input. Yeah, so in this case the step input will be 1 over m omega n u from 0 to t, and f tau, here the force is all the time force is mg over 2 only, so we write mg over 2, and sine omega n t minus tau d tau. Yeah. Okay. So if you solve further, what do you get? This is nothing but xt. This also we have done. We have applied a step input to this system and you have find our solution. So this is what the solution this will be. So xt will be root gs over omega n sine omega nt. This term is there, plus you get from here this f naught will be there, so you get f naught terms, so mg over 2 f naught over m omega n square term you will get. So m omega n square is nothing but k, so the k term will be there, and then from here you get simply 1 minus cos omega n t. Yeah, so 1 minus cos omega n t term will be there. So this is what we found. If you have a single spring mass system, if you apply a step input, you get this solution. This we have done in the class. Yeah, f naught over k multiplied by 1 minus cos omega nt. So this is the value. So if you add this and this comes from the initial condition and this comes from the step input condition. So both will be added. Initial condition in this case has to be added because omega n, because velocity at equal to 0 is not equal to 0. This is xt. Now we have to find out what? We have to find out time. And at t equal to 0, if you see, put t 0 here, so this becomes 0. T is 0 here, 1 minus 1, everything is 0. But there will be other solution as well, right? And then the other solution will be, for that we have to let's say x, we wanted to find out contact time tc, right? So next contact time will be when it is coming down. Yeah, and when it is coming down, when it comes down, it will have the same velocity but in the opposite direction. So that way also you can get a hint. Right now velocity is gs in upward direction. When it comes back, then velocity, well, I think velocity may be confusing because your force is also applied, which is 1 kilo only. But at least you can make xtc equal to 0, right? Again, so we will make xtc equal to 0, and from here that really means I will just write this side. So we have root gs divided by omega n sine omega n tc plus mg over 2k 1 minus cos omega n tc equal to 0. Yeah, we can combine it. So we get sine root gs over omega n sine omega n tc minus m over 2k cos omega n tc is equal to mg over 2k, or here also we can combine it. Sine omega term, you can combine it here. So let's assume this is sine, this is cos term. So we can assume this to be also a we can assume this is a cos, this is gs. So let's call it cos phi. Okay, so what do we get? So we get sine omega n tc. This is cos. this becomes sine, so minus phi. Okay, there will be a term here, let's call it A, sine this equal to mg over 2k. We get like this, yeah, where A equal to A will be the square root of this squared, so we get gs plus omega n square plus m square g square 4k square. Yeah, this is what the A will be. Okay, and then will be tan phi. So this is cos, this is sine. Yeah, so this is sine, so we get tan phi equal to mg over 2k divided by root gs divided by omega n. Okay, so everything is known here. A is known because here we have g, s value given, omega n is given, g, so all these things value are known. In tan phi also mg is known, k is known, so g root gs over omega n equal to root k over n, so all things known. So this is the condition, right? So finally what we will do, from here we can find out. So we get sine omega n tc minus phi equal to mg over 2k A, right? And then you can find out from here, right? Omega n tc minus phi equal to mg sine inverse. So from there you can find out sine inverse mg over 2ka, and the phi is known, hence you can find out tc equal to sine inverse mg over 2ka, right, plus phi and equal to omega n. So tc you can find out like this is the what it will take. Yeah? So here this is mg. So this problem takes a lot of understanding. You know, it's you have to look at not only from this course point of view, but all the courses you have taken earlier. Always, especially engineering mechanics, will be lot of application here. Yeah. So in dynamics, you studied this kind of thing. In fact, your high school, like a +1, +2 physics will also be applicable here. So what we have seen here is if some problem given which is not a vibration problem, meaning that the spring is not attached, for example, then you have to get into that condition where a spring is attached. Attached means it's in contact. And from there, the vibration problem starts. From there, you have to start the velocity or displacement. Yeah. So until then, you have to figure out like why this is given like this. So what is the significance? So finally, what is relevant for us is what is the initial velocity, what is the initial displacement. Initial displacement, we can assume in this case, from here the stretching is 0. In that case, the displacement is 0, right? So from there, so like that. Yeah. Okay. Any question, guys? Any confusion? Okay. I think there should be a negative sign before phase angle. Yeah, so negative sign before phase angle, that's what I did. So phase is, or maybe some, okay, so did you write for the some other question or for this one, Divanshu? You are saying, I think there should be a negative sign before phase angle. Was this for this problem or for different problem? If this problem, we already have my minus here, right? So minus phi I am saying. Yes, Aditi, the mg over 2 is a kind of a step, unit step force. That's correct. That is correct. Okay, the connection is very weak. So possible to send the recording later? Yes. Okay. Today I'm recording. Let me see whether it works or not. So if the video is recorded, then I will definitely send you. Okay. So I'm recording it today. Okay. Acha, in the previous question you had, in previous one, just check, okay? You may be right, okay? So just check. But in any case, it is the same thing. I mean, it will serve the purpose. Just check whether it was positive or negative. Doesn't matter. I think what I think this is a positive sign there, but you may be right. Yeah. So in that case, if that is the negative, then please correct it. Okay. Okay. Okay, great. Okay, how can we assume that this force will be as a step function? 5 will be adjusted automatically there. Okay. Okay. Now, how can we assume that this force will be a step function? A step function. So basically, uh, for okay. So why do you assume a step function? So a step function, this is a step function. A step function meaning that this is a constant. This is a constant force basically. A constant force when you are starting from t equal to 0, and at t equal to 0 itself, the force is mg over 2. That's number one. But it also has velocity, right? So this a given velocity v naught is there. V naught not equal to 0. Yeah. So this will the whatever the doubt you have will be compensated by this automatically. Yeah. So a step input for sure, even if this is existing from here, the real estate may be starting from here, but your time, this is t, but your time starts t equal to 0 here. For you, t equal t less than 0, you are not giving any respect. Your time starts from here only. So for you, the time starts from, you are assuming that before t equal to 0, this is this is not there basically. This all 0 is starting from like this one. Or think this differently. If you are not convinced this way, you can think differently. Let us say like this. You have an inclined, let's say you are in a space now, okay? You are in a space and you have like same 30-degree like this one, and you have a wall here, and you have a mass here, m like this one, and then you have a spring here, right? And then from here to here it is s. Yeah, we write k here like this. Okay, now you're in a space. However, this is made of iron. Let us say this is made of some iron or something, and you have some magnet like this here. Yeah, electromagnet like this. Yeah, so electromagnet. So that this will provide this one acceleration of g downward. But the thing here is we switch it off, right? I can switch on, switch off anytime. That's the idea, right? This is a switch here. Okay. Now, let us say this problem, can we think differently? Like, I give a constant velocity to this one. Okay. First, what I'm going to do, I give a constant velocity. How much velocity? V naught is equal to root gs. Yeah. this constant velocity I'm going, it's coming from, let us say, it's coming from far away, like this one. Yeah, constant velocity I'm giving it. Okay, but the moment this touches this one, I switch on. Yeah, I switch on the electromagnet also. Don't you think the problem is the same problem? It's exactly the same problem. At t equal to 0, the moment it touches the wall, you are also switching on the gravity, right? It has the same velocity as root gs. So initial velocity is because you have given initial velocity is a space, it will maintain, it will come. And the moment this is going to touch, you are also switching on the electromagnet as well, so that it also get the gravity, downward gravity. And hence you will see there is no difference between this problem and the original problem. That really means it is a step input. Convinced? Are the two problems different or same? Okay, great. So you think that way. As such, any constant value, you can treat it as a step input. Remember, okay? Any constant value, any constant force can be treated as a step input force. Remember that. Yeah? Any other question, guys? Other question, please solve. Okay, they are based on the next problem. Actually, I'm not going to discuss because of lack of time, but this problem, the other one, is also exactly the same kind of concept, but in fact much easier. Yeah. So the problem number, I tell you, the problem number is, yeah. So next problem, 414, yeah, which is 4.13. This problem based on this concept only, yeah, but much easier. You can do it. If you can do this one, you can do that also. Yeah. Any more question, guys? Anything that you could not understand, just let me know now. I said time is up, so we have to leave. But okay, what is if there is a friction force also? So then problem becomes a non-linear, you know. So then you have to apply the, you have to solve basically in okay. So if there is a friction force, then what happens? Okay, just quickly let me see. Okay. Okay, so if there is a friction force, let us say if there is a friction force, then what happens? So this is 30 degree, then like this one, this is m, then is a spread. In whatever condition, if you know the equation, you will solve it. Finally, comes back to the equation. Can you find out the equation? And equation in this case will be, you see here, equation will be this way, this will be, right? So we are assuming we have Coulomb friction, and because of this will be, force will be mu times r, we can achieve, right? Mu times r. Yeah. And what is r? In that case will be r equal to mu, then mg, then cos, right? This will be cos 30 degree. Yeah. So this is this one is the force which is being applied opposite to the motion, right? And then you have acceleration. There is another force which is this. This is mg sine 30 degree. Right? Yeah. Okay. So now, if that is the case, the initial velocity will change. You have to find out the initial velocity then. Now, initial velocity will be different in that case, right? Okay. So initial velocity, you find out from there. Again, initial displacement can be 0. You can still put it will be the same, only velocity will change. You have to find new velocity. Okay. Now the force, earlier you have the constant force, which was mg sine 30 degree only, but now we will have this also, the minus mu mg cos 30 degree. So your force will change. This is F naught. F naught will change. This will change in one direction only, though. Okay. So in one direction, okay, the other direction it will change. F naught equal to mg sine 30 degree, which will be like this one, and there will be plus also, plus mu mg cos 30 degree. Plus here, because the moment this changes direction, goes up, you will see that there will be a friction force which will be opposite to the motion of the mass. Hence, it will be plus sign here. So force you have to solve for going down. There will be one force. For going up, there will be another force, and you have to solve both of them. So that's the. It will make it complicated. Little bit. Got it? Okay. Any other question, Divyanshu? Okay. 4.7. Okay. Uh, 4.7. Just a minute. Ebook 4.7. Just a minute. Yes. Okay. So we have to use the equation. Yes. Okay. So I mean, let me solve it here. Okay. Yeah. You can use you can use the equation that we have derived in lecture, or it's very easy, basically very easy in a way. What I mean to say, just a minute. Huh? You can also, this is a property basically. Yeah. So see here, there are two things. One says show the response of unit function. So gt is for response, this one, right? So if this is for unit step function. If force is ut, then xt is gt, right? So like this one is related to the impulsive response, and impulsive response is this, like this one. Then xt is ht, right? So how will you find out? You can do with transfer function, right? Transfer function is nothing but this. Transfer function, you know that Ts is equal to xs over fs is given by simply this. If you take the Laplace transform of the impulsive response, automatically that is transfer function itself, right? So that's what we have done earlier. So actually this is equal to s, right? Okay. Now that means what? That means this is a transfer function. So for this one, if you have this, right? So gt, this is the response of gt. So gt equal to gs. Gs will be equal to transfer function times whatever the force, right? So fs, but force, our force is this one, unit step function. So ts is nothing but gs1, hs only, right? So ts is nothing but hs only. So we have hs times fs. Fs is for unit. So for unit force. So unit force, the Laplace of unit step function, right? And equal to hs. For unit step function, the Laplace transform is 1 over s, right? So what you get? You get gs equal to 1 over S HS, right? And then you take the inverse transform of this one. Then you get GT equal to, and if you get 1 over S, or you can write simply like this, HT, or you write like this, HS equal to SGS, and take inverse Laplace transforms now, both the side, HS equal to SGS. And what you get? You get this is becomes HT, and S times GS is nothing but G dot T, right? So you get like this. Yeah, got it? Okay. Okay, Divyansu, any other doubt, man? Okay, great. Okay, see you next week now. Okay.